అదే ఇప్పుడు గోవా లైవ్ కొట్టకపోతే అట్లా వచ్చేది. లైవ్ కొట్టాం కాబట్టి ఇట్లా వస్తుంది.
అదే పని 2 o'clock స్టార్ట్ అయితే పెట్టండి. 2 o'clock స్టార్ట్ అయితే
మీకు పెట్టలేదు గూగుల్ మీట్ లింక్
సెషన్ విల్ స్టార్ట్ అట్ 2 o'clock
లేదు ఇప్పుడు జాయిన్ వాళ్ళు 2 o'clock
అది జాయిన్ వెళ్ళిపోతే ఇంకా స్టార్ట్ కాలేదండి.
అందరికీ గూగుల్ మీట్ లింక్
అందరు పెట్టేశారా? ఎందుకు సార్?
చెప్పారు కదా సార్ డిప్లొమాకి సార్ చెప్పారు కదా సార్
పెట్టమని చెప్పి ఎందుకు సార్?
ఇంకా సర్ప్రైజ్ చేసి సార్ మనం కూడా ఫుల్ స్క్రీన్ పెట్టేస్తాం.
ఇప్పుడు ఒకవేళ ఏదైనా చేయడానికి చేయాలంటే బిజినెస్ చేస్తారు. దీని నుంచి ఏదైనా చేయాలి అంటే ఆఫ్ చేయడం, మైక్ ఆఫ్ చేయడం, ఆన్ చేయడం అట్లాంటివి
మనం ఇంట్లో ఆల్రెడీ లాగిన్ అయిపోతున్నాం. ఇంకొకటి పెట్టుకుంటారు, అదే పేరు పెట్టుకుంటాం యాక్చువల్లీ, కానీ ఇదే వాడతాం.
ఇదే వాడతారా? అందుకు ఇది వాడరా?
అంటే మనం చేయాలంటే ఇల్లు క్రియేట్ నడుస్తుంది అసలు. ఇట్లా ఇంగ్లీష్లో సెకండ్ లాగా ఉంటుంది. ఇప్పుడు నువ్వు సపోజ్ స్పీకర్ మాట్లాడుతున్నావు, స్పీకర్ మాట్లాడుతున్నావు అసలు
ఎందుకు సార్ అలా ఎందుకు
ఇక్కడ మాట్లాడాలంటే దీంతోనే ఉన్నానంటే దాంట్లో.
ఓకే గుడ్ ఐడియా
అయితే ఇప్పుడు ఇక్కడ నువ్వు ఈ అమ్మాయిని వస్తుంది, అబ్బాయిని ఇట్లా చేస్తావు, కానీ యూట్యూబ్లో వింటారు రాదు, ఇక్కడ హైలైట్ కాదు అన్నట్టు.
మీ విండోలకి మాత్రమే
పిల్లలు మన వరకే ఉంటారు అన్నట్టు.
ఇప్పుడు ఇంట్రొడక్షన్ శర్మత చెప్పారు
రెడీ అయితే అంత రెడీగా గ్రేట్ సార్ గ్రేట్. తెలియదు కదా ఎవ్రీబడి కానీ నేను మధ్యలో కరెంట్
మొత్తం మీకు
ఓబిఎస్ పోతే అంత సమయం వల్ల ఒక్క స్ట్రీమ్ అవుతారంటే కొత్త స్ట్రీమ్ వల్ల యూట్యూబ్ లైవ్ స్ట్రీమ్ యూట్యూబ్ ఛానల్స్ వాళ్ళకు వాళ్ళకు ఈ సిపి పడతారు సర్వర్లు వాళ్ళకు అన్నీ సెట్ చేస్తారు. లేకపోతే నార్మల్గా తీసుకొని దాన్ని రేటింగ్ వేసుకొని దాన్ని అప్లోడ్ చేస్తారు. లైవ్ రావడం తప్పదు ఒకటి లైవ్ క్రౌడ్ అయిపోయింది.
హలో
వేరే
మ్యూట్ ఫర్ ఎవ్రీ వన్ పెట్టేసాను సార్
Hello. Next session will start within 5 minutes. Slowly. Please close it.
అంటే సార్ ఇంట్రొడక్షన్ చెప్తావా
Culture sir. PPT. PPT. మీరు మీట్ కదా పీపీటీ ఉంటుంది ఏం చేయాలంటే అది పెట్టాలి చదవాలి మీరు పడప్పుడే నెక్స్ట్ స్పీకర్ ఇంట్రొడక్షన్
పీపీటీ పెడతారా సార్ చూడు సార్
జాయిన్ అవ్వాలి సార్ సార్కి
నడుస్తూనే ఉంటుంది కదా
ఏ నెంబర్ ఎక్కడ ఉంటుంది సార్
స్ట్రీమ్ అయితేనే ఉంటుంది సార్ ప్రాబ్లమ్ ఉంటుంది వాడుకోవచ్చు
సార్ హలో సార్ అదే సార్ జాయిన్ అయ్యారు సార్ మీటింగ్ కదా అదే సార్ అది సెషన్ స్టార్ట్ చేయండి సార్ మీరు జాయిన్ అవుతారండి ఓకే నో సార్ సే యూల్ జాయిన్ ఎగ్జాక్ట్లీ 2 o'clock సార్ ఓకే 5 జాయిన్ అవుతారు
అసలు అంత అయిపోతుంది కదా అంత అయిపోయినాక ఇక్కడ వచ్చి క్లోజ్ చేస్తాను ఓబిఎస్కి వెళ్ళి స్టాప్ స్ట్రీమింగ్ ఓబిఎస్ చూసినాక మళ్ళీ యూట్యూబ్కి వచ్చి ఇక్కడ ఎండ్ అవుతుంది ఓబిఎస్కి వెళ్ళి
ఫస్ట్ ఓబిఎస్లోకి వచ్చేయాలి తర్వాత యూట్యూబ్లోకి వచ్చేయాలి
ఎందుకు ఇక్కడ ఇక్కడ క్లోజ్ చేశాక అక్కడ అక్కడ ఓబిఎస్ ఏదన్నా అయితే వాట్సాప్
మీ ఫోన్ జాయిన్
ఎవరైనా ఫోన్లో వస్తుంది.
Vijay sir,
సార్కి జాయిన్ అవ్వండి, మెసేజ్ చేయండి.
అవ్వండి సార్.
హెచ్ఓడి ఆటోమేషన్ వచ్చింది. HOD automation.
Vijay sir,
సార్
సార్
did sir join?
ఎస్ సార్, సరే జాయినింగ్ సార్. సార్ విల్ 2 minutes
Sir
సార్
is
విల్
joining.
జాయిన్. లింక్ పంపించారా సార్కి?
sir.
Good morning, Anil Kumar, sir. Good
Hello,
afternoon, sir.
good morning, very good morning.
Yes.
Shall I open my presentation?
Yes, sir. I'll just give me a minute of time, sir. I'll introduce your kind self and then do it, sir.
Yeah.
Okay. I welcome all the participants for the post-lunch session on the day one. It's my pride and privilege to introduce the speaker of today's afternoon session, Dr. P. Anil Kumar Garu, scientist of RCI, DRDO Labs, RCI. Sir, may I go ahead in giving
Yeah,
you?
please.
Yeah. Dr. P. Anil Kumar has acquired his BTech Mechanical Engineering degree from JNTU Hyderabad with first class in distinction in the year 1998. He joined in organization, Defense R&D organization, DRDO, in the year 2000. He started his career as scientist B in the area of structural dynamics, dynamic analysis of subsystems and the systems of airborne vehicles using finite element methods. He has provided solutions for vibration problems in various electronic packages used in airborne vehicles. Unique solutions provided by him for vibration problems in one of the vehicle interfaces unit gave the sigh of relief for 150 units. From the wide spectrum of solutions provided, he has formulated guidelines for structural design of electronic packages and circulated among electronic designers of his laboratory. He has vast experience in conducting ground resonance testing of full scale airborne vehicles, structural load testing, and model testing. He has received Lab Technology Group Award in the year 2008, Lab Scientist of the Year Award for the year 2010, Agni Group Award for Excellence in Self-Reliance for the year 2014, Agni Group Award for Excellence in Self-Reliance for the year 2016, DRDO Group Award for Performance Excellence for the year 2016, and RCA Technology Group Award for the year 2008. He has 15 publications and one patent related to the present work. He wrote a book titled Basics of Simulating for Engineers, which is under review. Presently, he is editorial board member of International Journal of Mechanical Engineering and Applications. He did his PhD on design and development of metallic vibration isolators for airborne vehicles from NIT Warangal in the year 2018 under the guidance of Dr. P. Bangar Babu Garu. This is definitely a drop in ocean. Whatever we were being putting up to the August audience about the introduction of Dr. P. Anil Kumar Garu is very small. Whatever the works that sir has done it, whatever awards that sir has obtained it is really vast. Sir, I welcome you all from on behalf of MVSR Engineering College to take over this session, sir. Thank you very much.
Thank you, sir. Thank you very much, sir, for the nice introduction. Can you permit? Hello. Can you permit me to either attach the presentation or share the screen? I think I need permission from you.
No, sir, you can directly share the screen, sir. Present now.
There is an upward arrow beside this hand, raising
Same
hand.
thing I am trying. It is saying that some error has occurred in screen sharing. Can't share your screen. It is saying like that.
No issue, sir. Please take your time.
మళ్ళీ లాగిన్ అయిపోతా. ఇంట్లో ఉంటుంది. Sir, or else you can log off and log in again, sir. Rejoin the meeting. టైంకి కరెంట్ ఇట్లా ఇది మన బ్లాగ్లో అయితే బిస్కెట్ అవుతున్నాయి ఇప్పుడు మీటింగ్ స్ట్రీమింగ్ అన్ని ఇలా కొత్త మీటింగ్ కొత్త లింక్ పైన మన దాంట్లో బాగానే ఉంటుంది యూపీఎస్ బాగానే ఉంటుంది
నెట్ ఉండదు అక్కడ
నెట్ ఒక్కటే వచ్చేసాను ఈ 30 సెకండ్ కూడా అవుతుంది సార్ మరి స్టాక్ ఏంటి
లెఫ్ట్ మీటింగ్ అండ్ ఇల్లు రిజార్ట్
ఏమైనా చేయొచ్చు అవసరం
క్యాన్సిల్ ఫోన్ చేస్తారా ఫోన్ ట్రై చేస్తాను సార్ ఫోన్ చేయండి
కాల్ చేయాలా
కాల్ చేయండి ఏమేమి చెప్పండి
సార్ సార్ అది మనము పక్కన అదే ప్రజెంట్ బట్టి వస్తుంది కదా సార్ ప్రెస్ చేసినాక ఈ విండో వచ్చింది కదా సార్ ఈ విండో అంటే ఆల్రెడీ మీరు ఏ పీపీటీ అయితే ఓపెన్ చేస్తారో అది ఆల్రెడీ ఓపెన్ చేసి పెట్టాలి సార్ మీ ప్రజెంటేషన్ కానీ మీ పీడిఎఫ్ కానీ ఓపెన్ చేసి పెట్టి అది స్క్రీన్ మీద ఉంటే అప్పుడు ఈ విండో క్లిక్ చేస్తే అది చూపిస్తారు ఆ విండోని అప్పుడు దాన్ని క్లిక్ చేసి షేర్ కొట్టాలి
ఎంటైర్ స్క్రీన్ షేర్
ఇప్పుడు మీరు పీపీటీ ఏది ఇవ్వాలనుకుంటారో అది ఆల్రెడీ ఓపెన్ చేసారు కదా సార్ చేయండి సార్ ఓపెన్ చేయండి చేశాక ఇప్పుడు ప్రజెంట్లో ఉంది కదా సార్ గూగుల్ మీట్లో ప్రజెంట్ నవ్ అని ఉంది కదా సార్ ఇక్కడ హ్యాండ్ పక్కన అప్సెట్ బటన్ ఒకటి ఉంది ప్రజెంట్ నవ్ అని పీపీటీ ఓపెన్ చేసి మళ్ళీ గూగుల్ మీట్కి రండి ఇంకా వచ్చి ప్రజెంట్ నవ్ ఉంది కదా సార్ కింద హ్యాండ్ సింబల్ ఉంది కదా సార్ కింద దాని పక్కన సార్ ప్రజెంట్ నవ్ అని ఉంటుంది అదే సార్ అదే సార్ ప్రజెంట్ నవ్ అంటే అది క్లిక్ చేయండి సార్ ఏ విండో వచ్చింది సార్ ఏ విండో ట్యాబ్ అన్నారు కదా సార్ ఏ విండో అని వస్తుంది ప్రజెంట్లో క్లిక్ చేస్తే ఏ విండో యువర్ ఎంటర్ స్క్రీన్ ఏ విండో ఏ ట్యాబ్ అని వస్తుంది యువర్ ఎంటర్ స్క్రీన్ కొట్టి మీరు ప్రజెంటేషన్ కనిపిస్తారు యువర్ ఎంటర్ స్క్రీన్ అని క్లిక్ చేసి మీరు పీపీటీ అవునా ఈ విండో వస్తుంది సార్ యాక్చువల్ అయితే ట్యాబ్ సార్ లేకపోతే ఒకసారి నాకు మెయిల్ చేయండి సార్ నేను ప్రజెంట్ చేస్తాను ఇక్కడ మీరు వాయిస్ ఇవ్వచ్చు
మన కాలేజ్లో కాకుండా లేకపోతే పీపీటీ మాకు మెయిల్ చేయండి
ఆయన ఫోన్లో చేస్తాడు అనుకుంటా ఐప్యాడ్ నుంచి చేస్తారా డెస్క్టాప్ అయితే ఇట్లా వస్తుంది సార్, ఐప్యాడ్లో అయితే రా. ఓకే. సార్ మీరు ఎంటైర్ స్క్రీన్ క్లిక్ చేస్తే అది ఓపెన్ అయి ఉండదు సార్, పీపీటీ ఓపెన్ అయి ఉంటే ఎంబడే ఇక్కడికి ఈ గూగుల్ మీట్కి వచ్చేస్తే ఎంటైర్ స్క్రీన్లో పీపీటీకి వచ్చేస్తుంది. అదే సార్, మినిమైజ్ చేస్తే ప్రజెంటేషన్ మినిమైజ్ చేస్తే అట్లే ఓపెన్ చేసి పెట్టాలి.
మీరు ప్రజెంట్ అయిన ప్రాబ్లం మొత్తం ఏమవుతుందంటున్నారు సార్?
రావట్లేదు. ఓకే సార్, ఓకే సార్, ఓకే సార్, ఓకే సార్, ఓకే సార్. సార్ ఫోన్ చేసేయండి.
పీపీటీ మెయిల్ చేయనా? ఎత్తట్లేదా? ఇప్పుడు ఏం లేదు సార్? ఎవరు అనిల్కో ఒక 2 minutes టైం అంటే జాయిన్ అవుతాను. అనౌన్స్ చేసా, అనౌన్స్ చేసా బాబురా. బాబురా దాన్ని చేస్తా.
Are you able to see my presentation now?
Yes, sir.
Yes, sir. Yes, sir.
Am I audible?
Yes, sir.
Shall I start then?
Yes, sir. Please do.
Yeah. So, title of, first of all, I would like to convey my sincere thanks to I think head of the department automobile engineering MVSR college who has given an introduction about me, and I also want to thank the college management for giving this opportunity to share my expertise across faculty members or students who are the participants of this particular program. So, I would like to share my experience in this particular discipline. I have been using the finite element method and associated softwares, let it be MX ideas or ANSYS, for the past 22 years. And the way how I have grown in this area is from the day one we were working with experimental things also with close association. That is how we have graduated our skills and how best we can do the modeling in ANSYS so that whatever the results we get as an outcome of the analysis will be on par with the actual reality. I think you all must be knowing very well whether it is ANSYS or be it be Nastran, be it be Hypermesh, be it be ABAQUS. The philosophy on which these softwares will work is finite element method, which is an approximate method. It's not an exact method. So what we do is a guess. The outcome of the FEM analysis is a guess. Software to software, it doesn't matter much, but the basic philosophy on which we are working is it's a kind of guess only. So when you get into any commercial software package like ANSYS, it presents numerous modeling methods, and you'll be really getting confused slightly which modeling method is to be adopted. Like if you take a beam, there will be so many elements using which you can do the analysis. So you should be able to know what right element to be used and how you model the boundary conditions and all those things. So in my experience, because I worked closely with experimental things, whether it is static analysis or model analysis or random vibration analysis, because all the times I worked closely with experimental things, I could understand what are the best modeling practices. So with all that knowledge what I have gained during my tenure in DRDO for the past 22 years, this is 22nd year, I would like to share my expertise. But however, I am a mechanical person, so I have truncated my presentation towards automotive area. So I was just showing in form of slide what I was mentioning earlier. Any FEM software is considered as black box, and they say garbage in, garbage out. So user has to be very cautious about which input is providing to the software, because software is like a formula. If you give the input correctly, you will get the correct output. So I think I need not tell you, but just for the sake of completion, I am showing the commercial FEM softwares available starting from Unigraphics, Nastran, ABAQUS, ADINA. I think very few of you must be aware of this ADINA software. I think you all must be knowing one famous author in finite element method area, Mr. KJ Bate. He is the chief architect of this software. It is basically out of all these softwares, though many softwares claim that they have the non-linear solver, in my experience, what I have seen is olden days ADINA and presently ABAQUS. At present, ABAQUS is the software which is having a true non-linear solver. And just for your understanding, I have just shown many of my predecessors are speakers maybe which are coming in the who are coming in the later stage. They must be showing this basic analysis stages. You all must be knowing. I need not spend more time here. Pre-processing followed by solution and finally post-processing. What I would like to say here is you have to be extremely cautious during pre-processing phase. If you don't define the modeling practice, if you don't establish the modeling practice properly, you will be running into so many errors. So your accuracy of the analysis will be a questionable thing. And depending upon the software, the time required for analysis also will be judged. Similarly, when it comes to solution, different softwares incorporates different algorithms. Like you all know, ANSYS basically uses Blanco's algorithm. And the post-processing also, many people will be of the wrong opinion that we just have to press the button, software will produce the results. We have to just take the printout and present to somebody. It's not so. So as I was shown you in my first presentation, first slide, any software is like garbage in, garbage out. It is like a black box. So whatever the results it is giving out, let it be stress result or displacement result or frequency result or something else, you have to have your own judgment, you have to have your own assessment, and you have to clearly carefully examine the results, and you should decide whatever the results that are furnished by the software, whether they are appearing to be logical or not, before you present these results to somebody else. Particularly when it comes to pre-processing, this geometric modeling and meshing, loads, boundary conditions, all will be part of this pre-processing. Out of all, most of the time will take during geometry modeling. Many people make use of 3D element and then 3D geometry straight away. But in my opinion, in my experience, to the extent possible, you should not go for 3D element, because meshing with 3D element is the easiest task. But compared to 2D element and then 1D element, the 3D element accuracy, because basically, see, when you are doing FEM analysis, you have to be particular about quantitative and qualitative assessment. Quantitatively, 3D element may be definitely a suitable thing, but when it comes to qualitative, that is when you are talking about accuracy of the results, what you are predicting, so you have to be very careful. And boundary conditions also play a vital role. Boundary conditions is not that easy. And as I told you earlier, you have to be careful about the post-processing part also. Just for the sake of your understanding, many of you must be knowing, ANSYS is basically abbreviated like this: Advanced Numerical System Simulation Software. It's a commercial software package which will enable you to handle various versatile varieties of mechanical problems. So, what are the different analysis that can be done using ANSYS? Starting from static, model, harmonic, random aberration, transient dynamic, buckling, and contact. And similarly, some advanced level analysis also you can do it, like acoustic and design optimization, this CFD, and then fatigue also. Of course, when it comes to thermal front, you can do steady state thermal analysis, transient thermal, and then thermostructural also. Only one thing what you have to note down when you are talking about thermostructural is, at a time simultaneously you can't give both thermal and structural loads. First you have to do thermal analysis and for a given heat load, then you will be estimating the temperature distribution. So taking that temperature distribution, which is outcome of thermal analysis, and then giving certain constraints or boundary conditions, then you have to go ahead with the structural analysis, taking the temperature distribution what has been obtained as an outcome of thermal analysis as the load along with the structural load. Structural analysis will be done. I think you all know very well that ANSYS can be used in two popular modes. One is GUI mode, that is graphical user interface mode, which is very convenient for the user to deal with. I think these are the standard portions of any typical ANSYS front end. I need not elaborate these things, just for the sake of closeness I am showing. And this is another mode of using ANSYS, that is command mode. ANSYS can be, see, whatever the operation you normally do through GUI mode, you can, if you are an experienced user, you can even run the ANSYS even today with certain commands. If you see the last line of this presentation, slide, that is APDL mode, that is ANSYS Parametric Design Language mode. This has got a fantastic feature embedded in it. Many of you must not be knowing. See, suppose you are working in an organization where you have to do analysis for the nozzle. Let us say that organization is basically developing nozzles of different sizes, different dimensions, different materials. Then every time when you are doing analysis, every time it is not necessary that you have to start from the scratch. You need not every time start doing geometric modeling, then meshing, then boundary conditions. All that are not required. Once you do analysis for one time, and if you feel that your requirement is repetitive in nature, then the moment you complete the analysis for the first time, you will come back with a file with log as extension, .log. That file you can take it, and next time whenever you have to do the analysis for the nozzle with the different dimensions, or maybe with a different material, you don't have to again start from the scratch. You have to simply take the log file, you edit as per your new dimensions or as per new metal properties. Then you just run that log file. Then you just import that log file into your ANSYS window. You open the ANSYS window. Don't try to do from the scratch. Just get that edited log file loaded into this. Then just within no time, analysis will be done for the new configuration. That is one advantage with this APDL mode. And there are some standard file formats also. This DB file, DBB, all that I think you must be knowing. And see, basically, you must be wondering, the title of the program is, it starts with innovative. But why this fellow being scientist is showing all old or very conventional things? What I found is, what I heard from my friends or people or students who did so many projects with me, where they worked in ANSYS, and when they go for outside interviews, the questions what have been asked to them, what I could make out is, see, suppose whenever you are planning to join in some software company like Infosys or Tech Mahindra, basically Tech Mahindra type of things, where they induct people based on analysis, mechanical analysis background. They expect that you are expert in that software. See, before you claim that I have done ample number of analysis and ANSYS, before you claim that, you should be thorough with the fundamentals. See, what I came across, what I normally find is, people claim that we have done so many analysis and ANSYS, but many of them will not be true in fundamentals. So they will be getting, in fact, trembled when they are asked to explain the certain fundamental things like difference between geometric model and mesh model. People think that I will get geometric model, then when I click the mesh button, I will get the mesh model. It is not so. See, the geometric model, for you to understand easily, maybe during your curriculum, maybe when I don't know whether you have studied production technology or not. If you would have studied production technology, you must have come across through something called mold and casting. See, mold is a shape in which you pour the molten metal, then you solidify, you get the actual shape. So, geometric model and mesh model are almost analogous to this mold and casting concept. So, geometric model is basically required to ensure the actual geometry is considered for the analysis. As far as the software is concerned, software has no role to play with the geometric model. Software doesn't care for geometric model. Software bothers about mesh model only. Software will try to understand the geometry depending upon the elements and nodes and their respective positions. So, geometric model is required for you to get the actual model. So, it is not necessary. As far as the software is concerned, software will not put a condition that you have to do geometric model, then only you have to convert to mesh model. Software doesn't care for it. Software only looks for mesh model. So, we are the people who makes geometric model so that we get the actual shape of the object for which we have to do the analysis properly. We do the geometric model, then we try to discretize or do the meshing. So, otherwise, software needs only information about the meshed model. And as I told you, because you should not miss certain fundamentals. Another surprising aspect of ANSYS is ANSYS doesn't consider units for the metal properties. See, it will not ask you to code the unit. It will only ask in terms of numbers. When you are feeding Young's modulus, it doesn't say you specify the unit also. Whatever the number you give, it takes it. So, ANSYS is something like it expects that user will maintain the consistency. What I mean to say, when you are doing the analysis, when you are starting with the geometric modeling, if if you are giving numbers in units, then when you go for material property in ANSYS, you don't have option to change back to again other type of unit. From the beginning, you have to decide. In the beginning itself, you have to decide whether you will be continuing with unit, millimeter unit, or meter unit. So accordingly, you have to maintain the consistency. But however, this exporting and importing features are admissible in ANSYS. Whenever you are working with common metallic materials, particularly steel and aluminum, every time you need not define the metal properties. Either you can import, export and store like that, and it will be stored in the metal property library. And whenever you are doing new analysis, you can simply import it. And now, when it comes to analysis, as I said, it calls for modeling, that is basically geometric modeling and meshed model. And then sometimes when geometry is not so complex, you can also manually create the elements and nodes. And when it comes to loads, either you can define loads in preprocessor or through solution also. And when you talk about type of analysis, see this certain nomenclature will be there in ANSYS. LS1, LS2. LS is load step. LS1 basically, when you choose this option, you can give wind load type of thing. LS2 is load step 2, where you will be giving the gravity load. And when it comes to post processing, you can see time independent results, that is static analysis results, in post 1. Post 1 is a standard nomenclature that is followed by ANSYS. Post 26 is time dependent analysis visualization. So whenever you have to watch the results in terms of dynamic thing, then you will be getting into post 26. I have just brought typical elements which are available in ANSYS. Of course, some of the elements what you are seeing here may not be visible in today's version, but I just want to give you a feeling that what sort of elements will be available in ANSYS and what sort of degrees of freedom those elements will be having, and similarly real constants also. And this is how, of course, now today's scenario, shell 63 element is totally removed from ANSYS. And when it comes to 3D elements also, I think solid 45 is not there now. Similarly, some special elements also will be there. When you have to handle with pipe type of object, straight away pipe element is there, and this element is very popular. Combin is combination, where you can model both stiffness and damping. Particularly, this element will be useful when you are dealing with dynamic analysis. And very special elements are also there in ANSYS, that is something like rigid element, gap element, contact element, coupling element, and Winkler element. Winkler element is such an element which you normally use for civil type of application, where you are required to model the soil and all. Now you see the gap and contact element. See, when you have to do the contact analysis, see, one point what we are supposed to note down in our mind is these conventional elements like beam, shell, solid and all, they require a linear solver. But when it comes to gap or contact element, you can as well model the contact dynamics, but only thing is you will be depending upon nonlinear solver. See, you also have to bother about the efficiency of the nonlinear solver, that is algorithm that has been adopted by ANSYS. And this slide is very, very important, particularly for the students who are expected to appear in the interviews. See, when it comes to metal properties, when you are doing static analysis, the only two metal constants will be required. One is Young's modulus and Poisson's ratio. Density will not be really required. But when you go to dynamic analysis, be it the model analysis, be it the random operation, be it the transient dynamic analysis, apart from Young's modulus and Poisson's ratio, you are also required to give the density. And when it comes to thermal analysis, when you do the simple thermal analysis, that is steady state thermal analysis, only one property what you are required to define to the software is thermal conductivity. But when you go to the transient thermal, that is time dependent thermal behavior, when you want to study or when you want to characterize, apart from K, thermal conductivity, you also have to give CP rho, K rho CP, thermal conductivity, density and specific heat. When it comes to thermostructural, apart from this K, you also have to give alpha, coefficient of thermal expansion, and similarly Young's modulus and Poisson's ratio. Now I am slowly having touched the very foundation part of ANSYS. Many people will be getting misinterpreted that where to start. I have seen people, particularly students, complaining that Sir, in colleges, people doesn't teach us ANSYS properly. They simply deal with non-practical structures like beams and all. Our ANSYS lab has taught us only beams. They didn't teach us how to model the automobile engine and all. But still, I feel one need not blame, because why we always start with the beams is, see, when you are starting working, when you are started working on something new, you should also gain the confidence. See, as I told you, always one point which you should not erase from your mind is FEM, basically final element method, is an approximate method. So what you are doing is like a guess. There is no guarantee for the accuracy of the result what you are predicting. So particularly when you are in the beginning stage, if you start working with beams, what will happen is there are theoretical solutions available. So whatever you do in the ANSYS, when you try to work back from theory and when you try to compare the results of ANSYS and then theory, you will gain confidence. Yes, I am traveling in right direction. In the beginning itself, if you are aiming for doing the analysis of automobile engine or gearbox or something like that, you will be left nowhere. Whatever the result you are predicting, you will not be knowing whether it is correct or not. And there are some special features in ANSYS when it comes to analysis. Particularly when it comes to static analysis, sometimes you may have to deal with rotating objects also. I think you all must be knowing, when you are talking about static analysis, only one matrix will be there, that is stiffness matrix K, and two vectors will be there. One is load vector, that is F, and another one is displacement vector Q. So the general relation what you use for static analysis is K into Q equal to F. So whatever the load you give, say when you have to do the static analysis for a rotating object, let us take the example of a ceiling fan blade. The primary load that comes on the ceiling fan blade is its angular velocity. So when you have to define the angular velocity as a load, how software takes is, whatever the omega you are giving, software will calculate mr omega square, from which it will convert in form of centrifugal force. That much value will be dumped in your force vector. So when you do the analysis, static analysis for the ceiling fan blade, you will see the stress contours on the ceiling fan blade, but ceiling fan blade will not be visible as if it is physically rotating. But to the best of my knowledge, that feature is there only in ABAQUS. ABAQUS, when you see the stress contours, what I mean to say basically, when the object is rotating, at 0 degree, what will be the stress value? At 90 degree, what will happen? 180 degree, what will happen? So all that you have to do manually. But when it comes to ABAQUS, you can even see the stress contours when blade is physically rotating in that view. So that feature is there in ABAQUS. Same is not there in conventional FEM softwares like ANSYS and all. And you can also do the buckling analysis. Basically, you can buckling analysis is some sort of dynamic analysis only, though we call it as static. It is called eigenvalue buckling analysis. So you will be able to understand the failure mode. And thermal analysis, one important point what you have to have it in your mind, which may be useful for you to deal with in interviews, is when you are talking about edges of the object for which you are doing thermal analysis, ANSYS will treat all edges as adiabatic until unless you specify. So this point you have to keep it in mind. And when it comes to thermostructural, I told you, first you have to do thermal analysis, obtain the temperature distribution, then consider the boundary conditions or constraints, apply the external structural load, then you do the structural analysis along with thermal load. That is how you do the thermostructural analysis. So after giving the fundamentals of ANSYS, I will now make you to run through one case study, because now I have to, as I told you in the beginning, I have to limit myself towards automotive perspective. So I have actually guided one MTech student in doing the analysis of that particular chassis. See, you all must be knowing, I need not teach you, all of you are automobile engineers. So I need not teach you. In any automobile vehicle, when it comes to structural perspective, when we are talking about load-bearing members, chassis is the main load-bearing member, which takes care of almost all the loads of all subsystems and all. So we have taken this vehicle, and initially we started with static design. So this is the design philosophy what we adopted. The design goal is the strength to weight ratio should be as high as possible. and these are all the things we have to basically estimate. One is the selection of the chassis frame, and then we have to choose the material, we have to choose the cross section, and we have to work out the dimensions. These are the inputs what you have taken for this vehicle for us to do the analysis. Then these are the various functional loads that will be coming onto any automobile chassis. So you can see here bending load, torsion load, and dynamic load. In fact, dealing with the bending load is slightly relatively easy when compared to torsional load. Estimation of bending stiffness and all are very easy when we compare to torsional load, because in torsional load, see, many people think that chassis is like a beam type of member, so if we can estimate the bending load, nothing like that. But we also have to estimate the torsional stiffness. So that is also an important part when we are dealing with this chassis and all. Now, most of the cases we limit ourselves by doing static analysis, but it will not be sufficient. See, when you are talking about an automotive vehicle, you also have to ascertain its design adequacy in a dynamic environment, that is particularly vibration. So in this particular case study, what I am showing, that is more interesting. See, you would have seen definitely many reports, many papers which have dealt with static analysis of the chassis. But apart from that, through this case study, you will also know the importance of random vibration response analysis that you will be understanding. So basically, I think this nomenclature you all must be knowing. We have chosen a ladder frame type, and when it comes to load carrying members, basically the side members are expected to carry the shear force and bending load, but when it comes to the cross members, they carry the torsion load also. So having selected the ladder frame, there are certain associated advantages. One is mounting and dismounting will be easy to the when it comes to body, and various body types also can be accommodated. When it comes to the material, we have chosen a common structural metallic material due to its very good structural properties and strength. These are the metal properties I need not tell you. Now comes an interesting part. When it comes to cross section, see, you all know very well that there are different standard cross sections available. But in my opinion, compared to any other cross section, I cross section is the best one. For some reason, if I cross section is not possible, then you should go for box cross section. Box cross section means combination of two C cross section. Worst case is C cross section. So these three are the best cross sections available based on the hierarchy. So to work out the cross section, I have taken the standard. We have taken the standard bending equation, from which we got the. Of course, this is readily available. It is not something like that we have got. We have taken the expression for bending stress, and which basically wants us to estimate the bending moment. So we have assumed that chassis is something like overhanging beam, and then we have taken the associated formulation from theory, and we have estimated the bending moment. See, you can see the slide what I was showing you. We have taken three standard cross section. One is I cross section, box section, and then solid cross section. And then we try to compare the properties. So this Z by A ratio. Z by A ratio means Z is section modulus. You must be knowing. That is I by Y. And the ratio between Z by A. It basically it indirectly indicates the strength to weight ratio, which should be highest possible. And existing cross section of the vehicle which we have considered is solid, for which this ratio is very less. So as I told you, it is basically proposed to replace existing solid section with I section, as it has got a very high value. That is how we have chosen the I cross section. I also want to bring it to you. Compared to any other cross section, see, as I told you, any automobile vehicle, when it is moving on the road, it has to face vibration invariably, and that too, the nature of the vibration will be random vibration. See, that is why you all know very well why do we have shock absorber when you go on to the two-wheeler, or when you are sitting in a four-wheeler, when the vehicle is moving on the road, you experience some vibrations. Where from these vibrations are coming? These vibrations are basically coming from the road roughness and then speed of the vehicle also. So out of all cross section, I cross section is the best section. Not only for the strength to weight ratio, it will have highest vibration resistance in terms of damping. So that is why I cross section is the best cross section. So once the cross section is finalized, length and breadth are maintained as the existing, that is standard data that is available in the literature. Only cross section has been changed from existing rectangular cross section to I cross section, and then we have worked out the base model. And whatever the additional numbers are that are required, maybe for enhancing the torsion stiffness and all, that we try to add based on the iterative type of study which we have carried out with the help of FE model. Otherwise, the solid model of the chassis, when you see from the top view, it looks like this. The straight members, as I told you, they are basically meant for taking bending loads, whereas cross members are added basically to increase the torsion stiffness. This is how the solid model of the chassis looks like. Then we have gone ahead to the dynamic design. See, as I told you, any vehicle in general, it experiences very high random vibration. And this random vibration, when the vehicle is moving on the road, it gets transmitted from the road through the tires to the axle and then to the main chassis part. And in between, suspension system will be there. You know very well that what we have shock absorber and all. In case of two-wheeler, we call it a shock absorber. When it comes to four-wheeler, we call it a suspension system. This suspension system is expected to reduce the vibration what is coming from the road. So sometimes what will happen is suspension also will not be sufficient. Then we may have to change the suspension system so as to keep the vibration in limits. But always suspension system replacement is not possible. See, when you take the, I'm just giving an example, not to criticize anybody. We have this passenger type of RTC bus. When you travel in the passenger type of RTC bus, when you travel in the bench type of vehicle, maybe something like Volvo type of vehicle, you normally find difference in comfort because of the suspension system. Volvo will have advanced suspension system, that is pneumatic type of suspension system. Out of all suspension systems, when you take the conventional passenger type of RTC bus, it will have a coiled spring type of thing. It is something like an inferior suspension system. So then why can't you go for pneumatic suspension system for all the vehicles? Because it is very expensive. It's not a cost-effective solution. So though the primary objective of having a suspension system is to reduce the vibration, you can't fully depend upon the suspension system. So apart from dependence on the suspension system, you can also plan the proper cross section for the chassis in such a way that it also adds the good amount of vibration resistance or vibration reduction. As I told you earlier, this plot what you are showing here, this has been captured from one book that is Principles of Vibration Control, written by one Mr. Malik. He is professor from IIT Kanpur. He has done a study. He says out of all cross sections, standard cross section, diamond cross section, circular cross section, or rectangular cross section, I cross section will have the highest loss factor. Loss factor is nothing but damping. Damping is nothing but resistance to vibration. So now the point is, when you are talking about dynamic analysis, I feel very few of you must have dealt with dynamic analysis in ANSYS. So through this project, what we have done is, anyhow, see, the software is there. Software will give you the methodology, how to do the dynamic analysis. Dynamic analysis means basically 3 different types of analysis will be there. One is modal analysis, another one is random vibration response analysis, third one is transient dynamic analysis. See, I will explain you when random vibration is required, when transient dynamic is required. See, when the vehicle is going on the road, normal road, whether let it be smooth road or normal rough road, what you experience is something like sustained vibration. As long as the vehicle is going on the road, vehicle will experience vibration. That is sustained vibration. That is called random vibration. But when the vehicle has to pass over speed breakers or potholes, then a special dynamic environment that will be experienced by the vehicle, that is called shock. So instead of calling it as shock analysis, in software nomenclature, you call it as transient dynamic analysis. So when you have to assess the adequacy, design adequacy of the structure, and depending upon the requirement, either you do, sometimes you do random vibration analysis, sometimes you do shock analysis also. But whether you have to do random vibration analysis or transient dynamic analysis, carrying out model analysis is a prerequisite. So until unless you do the model analysis, you will not be able to do the random vibration response analysis. The special thing what we have done in this project is, in this case study is, as I told you, see, if you can learn how to do the random vibration response analysis in ANSYS software, you can do as well. But you will not get the confidence. Whatever the outcome of that analysis, whatever is coming from the software, whether it is it's a qualitative assessment or not, you will not be having a confidence. So for you to gain the confidence, what I did through this case study is I guided that student to do the random vibration response analysis without depending upon the software first, totally using the theoretical method. Then we try to validate with the help of ANSYS. That is how confidence has been gained. Yes, the results that are predicted using closed form solutions and ANSYS, they are in a good agreement. So I will just demonstrate how we proceeded with respect to theoretical dynamic analysis without depending upon the ANSYS software. To start with this, see, this is how we have taken the formula for natural frequency. Anyhow, for various standard beam configurations, we have the closed form solution for natural frequency. So in this, certain coefficients are required that also we have taken from the literature, and it also calls for some metal properties like Young's modulus, density, and then some dimension like length, and then it also meets moment of inertia. So when we have keyed in all the input parameters in this formula or in this relation, then we could estimate that first natural frequency is 62.5 Hz and second natural frequency is 121.6 Hz. And now when it comes to damping, see, once you complete the model analysis and estimate the frequencies, you also need the damping value. So from the book what I was mentioning earlier, that is Principles of Vibration Control, for the chosen cross section, we have captured the formula for estimating the loss factor. Then using different parameters like damping index of the beam material, that is steel, and ratio between thickness to the half of the height, we have calculated the loss factor. So the relation between loss factor and damping factor is half of the loss factor. That is how we have estimated the damping factor. Then this is the most challenging part. We have to do the random vibration response analysis without using the software. As we have seen, the chassis is having two frequencies only within the frequency range of interest, that is up to 150 Hz. See, this is also an interesting thing which you are supposed to know. What is the frequency range of interest? See, I just want to give a brief about vibration aspect also. Of course, you would have definitely studied during your curriculum. When it comes to vibration, shock is different. When it comes to vibration, the two standard forms of vibration are one is sine. See, when we study the vibration, we call it as harmonic motion, harmonic analysis. That is basically sine. And second one is random vibration. The difference between sine and random vibration is sine will be regular in nature. It is harmonic. It has some discipline. But when it comes to random vibration, it is not regular. It is something like irregular type of erratic type of behavior. It will have some erratic type of behavior. In case of vibration, you all must be knowing there will be two agents. One is victim, otherwise culprit. Culprit is road. When we talk about automotive vehicle, the culprit is the road, which is causing the vibration, and the victim is the chassis, that is automotive vehicle chassis. That fellow is getting affected. So these two parties are there. So these two parties will have their own frequencies. See, the road being culprit, when it is trying to impose vibration on the automobile chassis, it will try to convey this vibration while bringing the frequency element into picture. See, why frequency term is coming to picture is, see, you all must have studied maybe during your 8th class or 7th class physics a concept called resonance. The resonance is the most horrifying element in vibration. As I told you, always in vibration, two different parties will be there. One is the victim, other one is the culprit. So, as I told you, culprit will have its own frequency, victim will have its own frequency. And when these two frequencies are matching, the most damaging phenomena will come into picture, that is resonance. So, at resonance, what will happen is, the victim will have the toughest part of it. The victim will have very highly severe vibration. That is the beauty of resonance. So, when we are talking about automobile vehicle chassis, it is not sufficient that we only look towards the frequency part of chassis. We also have to worry about the frequency of the source, that is frequency of the culprit, that is frequency coming from the road. So, depending upon the transport means, when you are talking about rail type of transportation, the frequency content will be very less. One more point I forgot to tell you. The another difference between sine vibration and random vibration is, in sine vibration, at a time, only one frequency will be coming from the culprit. Only one frequency will be coming from the culprit. By any chance, if that one single frequency that is coming from the culprit, by any chance, if the frequency of the victim is matching with that, then victim will have a resonance problem. But when it comes to random vibration, see, why are we studying more about random vibration is, sine vibration is something like limited to books only. It is not practical. It doesn't exist in practice, to be honestly admitting. So, whenever you are talking about vibration, closing your eyes, you can say, yes, we are experiencing random vibration. Forget about automotive vehicle. When you are walking on the road, your body feels some sort of cyclic motion, some sort of disturbance. That itself is random vibration. So, in random vibration, on contrary with the sine vibration, what will happen is, no single frequency will appear. Instead, a band of frequencies will appear. See, for you to understand in a easier sense, I will try to explain the difference between sine vibration and random vibration with a layman example. Why I am spending more time here is, until unless you understand the significance of random vibration, you will not be able to appreciate the necessity for doing random vibration analysis for an automotive structure. So that the layman example, what I want to bring it to is, assume a case, you are standing in a chaurasta where 4 roads are there, you are just standing in the mid of the chaurasta or X road, whatever you call, and it is totally dark. And you have only one object in your hand, something like a writing pad, and you are unable to see who is standing away from you because of the darkness. Let us say one person is trying to throw the stones on you to damage you. Then you understood that you are unable to see that person. You are unable to see that person, but you have understood that from only one direction stones are coming. Then what do you do? Whatever the writing pad that is there in your hand, you will protect your face or head with that writing pad, so that whatever the stones that are being thrown by only one person can be dealt with. With that writing pad, you will protect yourself so that the stone will not damage you. So that is the situation of sine vibration. Only one frequency will be there. But when it comes to random vibration, now you assume you are standing in the same chaurasta, you have only one writing pad. Now what is happening is, so many people are standing around you in darkness. You are unable to see them. So all of them, what they are doing, they are trying to throw the stones simultaneously. So many stones are coming, so many stones are being thrown on you simultaneously, but you have only one writing pad in your hand. You will not be able to protect yourself. That is random vibration. So many frequencies will come from the culprit together. So that is why random vibration is more damaging, more complex, and more important to be dealt with. So, in almost all the practical applications, not only automotive, be it be industrial application, be it be aerospace application, be it be a simple application, as I told you, when you are simply walking on the road, whether it is with barefoot or with shoe or with chappal, your body will experience random vibration. So random vibration will come everywhere. So-called harmonic vibration, that is limited to book only. In a practical scenario, nowhere vibration will come with only one frequency. Always vibration will come with band of frequencies. So many frequencies will come together. So that is where random vibration becomes more important. Okay. So depending upon the platform, when you are talking about rail type of transportation, there you get up to 100 Hz only. All the frequencies up to 100 Hz will appear from the victim, but from the culprit. Now, when it comes to road, when you are talking about automotive application, the frequency range of excitation that comes from the culprit is up to 150 Hz. And as you have seen, when you have done the estimation of natural frequencies, you understood that within the frequency range of interest, only two frequencies are there. So for you to deal with the random vibration response analysis in a theoretical manner, now you are forced to deal the chassis or treat the chassis as a 2 degree of freedom system. See, when it comes to 1 degree of freedom system, when there is only one frequency within the frequency range of excitation, doing random vibration response analysis using theoretical method is as easy as drinking water. But beyond 1 degree of freedom system, beyond one frequency, when you have two frequencies or more, then treating it as theoretical thing is very, very tough. So this is how the formulas are there. We could get from some standard and very, rarely available literature, and we have to do some derivation, mathematical derivation also. This is how we got the expression for response in terms of displacement. And then what we have done, whatever this formulation we could establish for estimating the random vibration response, for the sake of best utility, we have developed a software using MATLAB. See, you all must be knowing MATLAB. MATLAB is a programming language. We can write the programs, but MATLAB has got so many features. MATLAB has got GUI-based features, graphical user interface. The best example is you take the digital calculator in your computer. See, when you want to use the digital calculator in your computer, only certain buttons will be visible to you. Numbers will be there, multiplication, addition, sign, cos, all the symbols will be there. So you will be just clicking a specific button and your result will be produced. But you know it or not, for you to use the calculator, for you to get a certain mathematical operation to be done, the back-end program is written in Visual Basic mode. See, the computer in which digital calculator is there, it is not necessary that it should have Visual Basic software loaded. Without loading Visual Basic software also, still digital calculator in a computer works. Because once we develop a particular software, if we can convert into exe type of file, then you can use that file in any PC where that particular software is not there. What I mean to say, the program we have developed in MATLAB, and once we convert into exe type of file, that file can be loaded in any computer where you don't have to have a MATLAB software. And the additional advantage with the GUI-based feature is you don't have to get into that mathematical formulation. You don't have to get into complexity at all. The GUI-based type of thing will provide certain buttons or whatever it is, where you can simply enter the inputs. The front end of the software you are seeing, it is probing you to enter certain inputs. So when you enter the inputs, and when you click this bottom side output buttons, first natural frequency, second natural frequency, damping factor, overall dynamic displacement, straight away these results will be getting displayed. When you click the plot button, you get the response spectrum. So you don't have to worry about the formulation. You don't have to worry about, you don't have to get into MATLAB. In fact, you need not know the MATLAB software. See, somebody has developed that, you are using it. It is as same as digital calculator. So this is how we have developed. Then whatever the results we have estimated using theoretical method, for us to validate it, then at that point of time, we try to do the same analysis using ANSYS software.
30 seconds.
As I told you in the beginning, this is something like a flow chart which we have adapted to do the analysis in ANSYS. We basically started with geometric model, then we gave the desired material properties starting from Young's modulus, density and Poisson's ratio. Then we gave the desired boundary conditions. We are also supposed to give certain physical properties like cross section, and then we gave the loads also, that is weight and then dynamic load. And then as part of static analysis, we have estimated 1 mesh stress, and as part of model analysis, we have estimated natural frequencies, and as part of dynamic analysis, we have estimated the vibration response. So this is how we have done the static analysis using Hamilton method. We have estimated the bending moment, and we have also estimated the bending stress. And this is the FE model with the beam element. And first natural frequency has been estimated by carrying out model analysis in ANSYS. And the second natural frequency also is obtained. That is the second mode shape. And we also finally did the random vibration response analysis. See, now you see the interesting part. See the results obtained using theoretical formulae and theoretical calculation, how close they are with ANSYS, maximum bending moment. Even whatever the bending moment we calculate using theoretical calculation, we could estimate it through ANSYS. And similarly, bending stress, first natural frequency, second natural frequency, and finally overall dynamic displacement. They are in good agreement. And basically, what we want to establish here is it is not necessary that we have to depend upon commercial software. See, I am not blaming any software package. What I mean to say, for you to gain confidence about the subject or about the theme which you have taken, if you can make a, in fact, we have struggled a lot. Initially, we thought we will do it with at ease, but for finding out for establishing the formulation, for doing random vibration response analysis without depending upon the software was not an easy task at all. We struggled a lot. And finally, the formulation, whatever we established for carrying out random vibration response analysis was appeared to be correct when we try to validate with ANSYS. See, what I want to say with the utmost confidence, whatever the features that are available in commercial software like ANSYS, that we could establish using a typical programming language like MATLAB. See, all these outputs, whether it is natural frequency or damping factor or dynamic displacement or bending moment, bending stress, all that we have developed a parallel platform using which also analysis can be done. So that was our expected outcome. And you can also see not only in terms of numbers, the displacement pattern, how it is matching between theoretical calculation and ANSYS. And though the topic given to me is to speak about ANSYS and then analysis, what we do when it comes to automotive perspective, I think I am exceeding the limits what have been stated to me for the benefit of faculty members or students. See, as I told you in the beginning, doing analysis is not a great job. I want to tell you with utmost confidence, with utmost guts. Doing analysis is as simple as that. There are so many people in the lanes of Hyderabad, who can teach you how to do the analysis. It's not a big job at all. It's not a great job at all. But as an automobile engineer, my strong recommendation is you should work on experimental things also. You should know how to measure the vibration for an automobile vehicle. We have been working for the last 22 years how to measure the vibration. Why I want to say is, in today's scenario, see, what is the expectation of an automobile engineer who is coming out of the engineering college? He should get a good job. So most likely, except a few people who wants to visit abroad and all on the name of MSR, whatever it is, many of you are must be having a desire to get a core job, that is automotive sector. So what I feel is, just knowing how to do analysis will not be sufficient. See, today why I came forward to give my talk is, see, till now whatever I have shown, I almost spoke like a teacher. But beyond that, what you are supposed to know, that I want to show from now. So basically, today's scenario, all automotive institutes, whether it is TVS or Mahindra, anybody, they are actually in the dead need of people who can provide measurement support for them. Why I am saying this is, you all must be knowing, for any new automobile vehicle to be launched in the market, there will be some regulating bodies. They will ask them to show the vibration values, because see, in today's scenario, unlike olden days, we are not spending only thousands, we are spending lakhs. So when we are spending money, the prime expectation of the customer is the comfort, utmost comfort, whether it comes to a passenger or whether it comes to a cargo in a cargo type of vehicle. Utmost comfort is the main thing. So every vehicle manufacturer has to show that when it is transported, when it is mobile on the road, the vibrations that will be coming onto the vehicle, they are well within limits. Until unless he establishes that, he will not get permission to launch the vehicle. His vehicle will not be allowed to move on the roads. So vibration measurement exercise becomes very, very vital. It has become a vital requirement. So almost all the automobile manufacturing companies, they are expecting the engineers. By the time they join them, if they have sufficient knowledge, hands-on knowledge with respect to measurement, not only vibration measurement, people are looking for people, employees or fresh recruitees who can do strain measurement. Vibration measurement, strain measurement, they are very, very important. Strain measurement to some extent, you don't have to put your brain to a great direction, but vibration measurement will be at most curious. So this I want to show you. See, as I told you, the necessary for the measurement already I have explained you. So one point is, the first and foremost point is the structural integrity. See, when the vehicle is transported from Hyderabad to Karimnagar, it should not so happen that bolts and nuts, they get loosened. See, the way the vehicle has been integral before transportation, before movement is started, the same type of integrity is expected to be exhibited by that vehicle once the transportation exercise is completed. And everything is fine. Then you don't have to measure the vibration. Why then vibration measurement is required? When something goes wrong, the measured vibration will tell you where exactly the vibrations are coming high and how to reduce the vibration. See, today you manufacture a vehicle like this. Unfortunately, when you are making this vehicle to move on the road and when you measure the vibration, let us say vibration levels are very high, 1000 units and all. You cannot say this vehicle is discarded, this vehicle is useless vehicle, because you already spent effort and money on that. So what you have to do, you have to do some design modification. For that only you are called as an engineer. Engineer job doesn't end with the design. He has to give solution to the problems. So you have to modify the design. For you to modify the design so that vibration levels will be within limits, the prime input what you need is the vibration levels. So that is how genesis is formed for vibration measurements to be taken. And these vibration levels are to be measured with different conditions, with the different road conditions and then different vehicle speeds also. As I told you in the beginning, vehicle suspension system, many people has a wrong notion. See, as you are seeing in the photograph, I think you all must be able to make out. This is called leaf spring suspension system. Many people feel that this leaf spring system is just to carry the load of the vehicle. Of course, that is also a duty, but the main objective of the suspension system is to provide vibration reduction between tire and the axle. So how the suspension system is behaving, how to what extent it is reducing the vibration, that you will be able to establish practically only through vibration measurements. What you have to do is, you have to measure the vibration before the suspension system, you have to measure the vibration after the suspension system, through which you will be able to understand the functionality of the suspension system. And see, in many vehicles, even you see the normal conventional DCM type of vehicle, you just put your head down and you see almost all the vehicles will have leaf spring suspension system. Actually, many people doesn't know the like when it comes to fruits, always will be behind the costly fruits. We feel that if we eat apple, if we eat some other fruit only, our health will be good. But there is a simple and easily available fruit in the market, that is guava. See, guava possesses all the qualities what apple has. And more and above, some more qualities will be there in guava which will not be there in apple. Like that, this leaf spring suspension system is treated very in an inferior manner. People always look for pneumatic suspension system, which is more expensive. But leaf spring suspension system has got a unique feature that it's called constant natural frequency suspension system. What I mean to say, see, each vehicle is supposed to carry some load. Each vehicle is supposed to carry some load. For some reason, vehicle is underloaded. Some reason, sometimes vehicle is overloaded. Even then, the construction of the leaf spring is such a way that the leaves will come close by, or sometimes they go far apart. So the distance between individual leaves in a leaf spring system, that is variable. If the higher load is put on the vehicle, the leaves will come close to together, and accordingly stiffness will be high. And when the load is less, the leaves will go away from each other. Accordingly, the stiffness will come down. So you know very well that frequency is nothing but ratio between K by M, that is stiffness and mass. So as per the varying load, its stiffness also keeps varying. When the load is increased, when the mass is increased, K will increase. When the mass is getting decreased, K will reduce. So all the times, natural frequency of the suspension system will be maintained same. See, I am not getting into details. The natural frequency of the suspension system is supposed to be some value. So when the load on the vehicle is changing, is because mass is changing. If the frequency of the suspension system is changing, then its vibration reducing characteristics will get affected. So the beauty of the leaf spring suspension system is it maintains always the natural frequency as same in the order of 3 to 5 Hz, irrespective of the load that is coming onto the vehicle. So for you to deal with vibration measurements, you need certain infrastructure. See, for colleges like MVSR college, if I would have been giving this lecture in any other normal, typical private engineering colleges, I would not have shown these slides at all. For a college like MVSR college, which has got, please don't mind I am making this comment, I assume that it has got plenty of resources. So I sincerely suggest, instead of just training the student only on theoretical things, I feel you must get certain infrastructure into your laboratory. You should upgrade your laboratory. In fact, we will be helping you what sort of experimental infrastructure you need in your laboratory, so that by the time automobile engineer is leaving your college, he is not just fed with the theoretical knowledge, he is also fed with experimental things, how to do the vibration measurements. If he is trained in this area, by the time the automobile engineer is leaving the MVSR college, if he has been upgraded, if he has been trained in the area of vibration measurements, you yourself can throw a challenge to the automobile companies. You come to our place, you will find diamonds in our college who are also trained in experimental part, who are also trained how to do the vibration measurements. You can just it is something like plucking a fresh fruit from the tree and just start eating. So you can just take the student from our college campus, you can just lift him, get him there in your institute without giving any training. He will be useful to you. So to claim to that extent, so I sincerely suggest colleges like you please upgrade your laboratories with these systems. Then you don't have to put a very high value of money. So if you get all these systems like vibration data system, and then see different types of data systems are there. See, today data system looks like this. See, data system is, don't get confused. Basically, what you need is accelerometer. Of course, though I have not shown here, accelerometer is the sensor which measures the vibration. So that vibration signal that has been captured with the accelerometer or sensor, that needs to be fed to the computer where you see the vibration. So this fellow acts as an interface between the sensor and your computer where you do the post processing of the data. So if these things like sensor, vibration data system, if you can get these systems and then they are put in your laboratory, students can be trained in the area of vibration measurements also. In fact, we are there to support you. So my sincere suggestion is, don't stop to the extent of just designing or developing or doing only analysis. See, I feel very pity. I am very sorry to throw this comment. I feel very pity when people say, I have participated in this robo workshop or in this robo workshop, I have developed this robo, I also feel pity on the students when they say, I participated in this, I'm unable to recollect the name. Some competitions will be there, particularly for automobile engineers. Some automobile frame type of structures they'll be making. All those things are not of practical use. When you have to exhibit, when you have to demonstrate yourself that you are a real expert in the area of automobile engineering, you must work in this vibration measurements area also. If you are only saying that I have developed one robo or I have participated in some competition, I am unable to recollect that name, doesn't make any sense. See, today automobile manufacturing company doesn't see how many robos you have made or how many competitions you have participated. They only need the practical people with practical knowledge. So I once again sorry, please don't think that I have criticized robo, because today also I feel very unhappy. In a market, when I am suffering with cockroaches in my washroom, I have a hit product available in the market with which I can get rid of cockroaches. But when I am living in an apartment, when I am staying in 10th floor, when I have to carry 20 kg, 25 kg rice bag, when I, let us say, I'm not of that age, if I am 65 years old person and my lift is not working, how do I carry the 25 kg rice bag up to 10th floor? Is there any robo available in the market readily I can purchase with 5,000 rupees or 2,000 rupees, so that using that robo, the item can be taken along the steps? Is such robo is available in the market? We have been talking about robotics for the last 15 years, if I am not wrong. So please don't think that I am criticizing that area. But the message what I want to convey is, you should be for you to get good settlement first. You should be having knowledge in a practical scenario. If you are living in your own world, dream world, I have participated in this competition and I have developed these robots and all, that doesn't make any sense. It will only enrich your skills. Instead of that, if you are working on this type of things, vibration measurements and all, particularly for automobile engineers, it will be really useful. And see that whatever I have been telling, I have just compiled in one slide. See, these 4 things, particularly serial number 3 may not be useful to you, and serial number 1, 2 and 4. In fact, we can guide you from RCS side. See, if you can establish the necessary infrastructure in your college or in your laboratories to carry out this strain measurement, and then model testing, how to do the model testing and vibration measurement. The students, if they are trained in these 3 areas, serial number 1, 2 and 4, ignore number 3. This is not so useful. So, in fact, serial number 2, I want to tell you, we have model testing. This model testing is don't get surprised. What is this model testing? See, whatever the model analysis you are doing, whatever model frequencies, whatever natural frequencies, whatever the mode shapes you are predicting using your ANSYS, all that can be done experimentally, for which you need this model testing hardware. So, I want to tell you one example. Though I don't have that slide to show it to you, Tech Mahindra company, you know very well, Tech Mahindra company deals with so many projects where they do analysis of so many automobile systems. But unfortunately, they don't have experimental model testing facility available with them. Around 7 years before, Tech Mahindra team approached us. They did the analysis for the steering column assembly for one of their clients. Their clients have put a condition to Tech Mahindra. Whatever the theoretical results you have predicted using analysis, ANSYS, you please also establish through testing. Because they were not having testing hardware, they approached us and they got the hardware to us. When we did the model testing at our place, to the surprise of Tech Mahindra, the results, the model frequencies, what they predicted using ANSYS with 20-25 years experience, found to be wrong. Because, as I told you in the beginning, when you are doing the analysis, you have to be extremely cautious. You have to model boundary conditions properly, because certain flexibility, what is associated in the steering column assembly, because they are not considered properly, they missed certain frequencies which have been found in model testing. Then, when a new frequency found in model testing, again they went back. In fact, we gave them solution also. We explained them why they would have missed the frequencies. We taught them this is how you have to do the modeling. And when they went back and when they changed their model, their predictions were matching with model testing. So what I mean to say, until unless you work with experimental things, let it be 100 years experience you are having. That if you are saying that I have worked in ANSYS for 30 years, 40 years, doesn't make any sense. Until unless you have practical experience, your skills cannot be made use of. So with this slide, I like to conclude the presentation. Thank you once again. I thank the college management to give an opportunity to share my expertise with you. Now I open the forum for any queries.
So all participants, if you're having any queries, you can ask the sir. Any doubts from the participants? So all the participants, if you're having any queries, you can post your queries in the chat box, or you can ask directly ask the question. Sir, I think there are no questions from the participants.
Okay.
Sir, so we'll conclude our session here to all the participants. So we'll give the vote of thanks to sir. Sir, thank you very much for your valuable information, sir. So from the starting, you have explained everything regarding the finite element analysis, and you have also briefly explained us about the experimentation of the vibration measurements, and you have guided us how to make use of the experiment. So thank you very much, sir. So we will close the session here.
Sir, just a second.
Yes,
Can
sir.
I speak, sir?
Yes, sir.
Sir, I am happy that I was able to join your program.
Thank you, sir.
Hello. Are you able to hear me, sir?
Yes, sir. Yes, sir.
Are you
Yes,
able
sir.
to hear me, sir?
Yes, sir. Yes, sir. Kindly ask the question.
Thanks, sir. Thank you, sir. Thank you for sharing the information regarding experimental testing also. Sir, you have quoted that you can have the measurement of some of the parameters, something related to strain as well as, vibration.
Yes.
Sir, I may mention that all the institutes may not possess such facilities. Sir, do your institute have such facilities and offer some consultancy in that issue?
Yeah, definitely. See, it is not actually. I am not from institute. I am from a DRDO establishment, DRDO laboratory.
Okay.
I'm a scientist working in DRDO laboratory.
Sir.
We have all these facilities available at our place. We can offer definitely consultancy to you. And what I want to say is, whatever I am saying, it is actually one-time investment. Investment. If you like, see, from the day I studied diploma and then BTech, I used to see physically engines, automobile engines put in the laboratories. They would have done only one-time investment, but from that, so many batch of students must have got trained. So we can offer consultancy. We can show you. We can train our people how to do the vibration measurements and strain measurements.
Actually, I may not bring my personal issues into this, but just I want to mention,
Yes.
I have been checking for strain measurement for making a measurement related to Young's modulus and Poisson's ratio. Simply, for example, say, the common problem what I faced was the normal testing centers, they don't offer that facility because their extensometer will break away.
Okay.
So in that case, I felt that I should have the strain gauge set up. I should paste it on my own for my specimen and perform the measurements. But when I try to inquire about the price for that such type of measuring equipment, say the data logger or say amplifier, whatever it is, the costs were found to exorbitant.
Now, what I want to say, sir, actually, if it is for training your students, as I told you, then you can buy all that equipment. If it is for your one-time research requirement or research application, what I suggest is the same person who is selling these systems, data system, strain gauge and all, he can be hired to meet your one-time requirement. He will come with all the necessary. It is something like hiring a system for only one time.
Achha.
Instead of buying, just for one-time research requirement, I don't recommend to buy the entire system. As you said, cost aspect is very high. What I want to say, maybe for your one-time research requirement, you can even take the support from those suppliers who will come and do the measurement work for you at your place.
Achha.
There are actually, what I want to say, without confusing you much, what I want to say, if you want to establish it as a permanent setup in our college so that your students will be trained, then you have to put that much investment. You have to buy all those systems and then put it in your institute. But if it is for your one-time research requirement, what I suggest is you can hire the services from those people.
Mm-hmm. So the people whom I contacted could not be hired. I even for that also tried.
Okay.
So that's why I felt somewhat fascinated when you gave such presentation.
Okay.
Can you share any contact if you have like that, sir?
Yes.
Of course.
Yes. You can share. I can share.
HOD sir, automobile engineering. I'm very thankful for you for organizing such a good program.
I think, can you note down the number?
Yes, sir, definitely.
9849 487
125.
His name is Srinivas. He is actually supplying this all strain data system, strain gauge and all. He is a fantastic person. He can definitely provide you this one-time activity, one-time support.
Okay. Thank you, sir.
Only thing is, at your end you may have to do the setup for the loading type of setup. He will be able to provide you strain gauges. He will provide you the strain measurement.
Sir.
The loading part and all you may have.
Okay, sir. We have a good UTM.
Okay. Right. Then nothing like that. UTM is there nothing like that. The strain gauges and strain data system this fellow will provide undoubtedly. You can quote my name that I have referred. You can just get the service.
Right. Sir,
Thank you very much. Thank you very much, Ravi Kumar Garu, for all that particular information which you have given it.
Sir.
So, I was carrying my mobile and then I'm listening continuously instead of my official schedule.
Sir.
What I could understand is research is not just talking more than what fundamentals are. They start from fundamentals and go ahead in providing all the wonderful information.
Sir.
Department of Automobile Engineering, MVSR Engineering College, on behalf of management, faculty, staff and students, thank you very much for this wonderful lecture, sir. And we will definitely associate with you in the coming days.
Thank you, sir. Thank you very much.
Because we have association with Bangar Babu, sir. And all your papers are with Bangar Babu, sir. Definitely, sir, we will see to it one day you are there with us, with our team, sir.
Okay.
Thank you, sir. Thank you very much. Thank you, sir.
Then shall I exit, sir, from this?
Yes, sir.
Yeah.
Yes, sir. Thank you, Sundarraj Ravikumar Garu, for the interactive things. This is what students should learn. Students should definitely interact and they should learn things. They should take out contacts. They should establish research innovatives. Thank you, Sundarraj Ravikumar Garu.
Sir, thank you, sir.
Yeah. Sir, may I know from which college you are?
Sir, I am from NDCAR Institute of Science and Technology, Vidyanagar, Vakadu.
Oh, nice meeting you, sir. It's my pleasure to see to it that you're on board with us today.
Sir, thank you.
In spite of your busy academic schedule, interacting with the students, in the background, I could see that particular commitment.
Sir.
And we will try to tie up with your institute also. We'll take it ahead, sir. We'll not leave this at any particular point of time.
Sir.
Because MVSR Engineering College, Department of Automobile Engineering are more into development of all-terrain vehicles. We were standing all India 10th in making of SAE Baha vehicles.
Sir.
And we are into electric vehicles also on hybrid train. We are doing research on NVH. We are doing research on some AI-based things to find honkers on traffic of Hyderabad. So there is one particular project which we are doing it. So we'll see. Definitely, we'll have association, and my students also learn most of the things from you all. Thank you very much, sir. Tomorrow, let's meet. Tomorrow morning, let's meet. We have very exciting talks tomorrow. The first talk will be tomorrow morning, 10 o'clock sharp. Will be on metal forming. How ANSYS is used in metal forming techniques by Dr. J. Kandaswamy, followed by EDS technologies, ABAQUS. That's a it's a industry people who are doing a lot of consultancy work using ABAQUS. And tomorrow we have three sessions. The first session is metal forming by Dr. J. Kandaswamy. Then static analysis, that's hands-on experience. They'll start from scratch and make a model, and from there how you apply loading and interpretation of results under static conditions and in dynamic conditions. So I wish you all the best, and tomorrow please see to it you don't miss the things. And for students, we are converting this particular workshop into CAE internship because of the pandemic. Those who could not attend to industry, they can claim this particular certificate in online mode. Hence, attendance is compulsory. We are automatically taking attendance through Google Attendance Sheets, which is compatible with Google Meet. Hence, I request all students to see to it that you attend, you learn, and you apply in your projects, prosper, and do good to the society. Thank you very much. Right. Thank you, Vijay.
Thank you, sir. I request all the students to fill the feedback form which I posted in the chat box. It will consider as attendance. So once your feedback form is filled, you can leave the meeting. Thank you all.
సిమెంట్లో వచ్చింది ఎందుకు మీటింగ్ క్లోజ్ చేస్తారు